Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
In this video segment, I'm going to be demonstrating how to create graphical user applications, Win32 applications, using Microsoft Visual C++, using the Visual Studio IDE, File, New Project option. Once you get to this menu, New Project dialog, you will see some subcategories under Visual C++. You'll have MFC category. You also see a Win32 category. It's kind of interesting because MFC includes Win32, but if you want to create a graphical application without using MFC, that's Microsoft Foundation classes, you can do so here. That's this Win32 project. It's actually a graphical project, does not use MFC. It's really not C++. I mean, it's a C++ file. But you could really compile this as a C module pretty easily with very few changes. However, extending it, adding more visual components can be very difficult. It's a very basic graphical application. I can go ahead and demonstrate what that looks like here. So you have a lot fewer options if you don't choose MFC. We're going to say, it's a Windows application, although we already chose that. We're not going to use Active Template Library. So you don't get a whole lot of options. It does generate a lot of code for you. And you can run this right away. So this is what it looks like if you create a brand new application in Visual Studio, Visual C++, and do not choose MFC. And like I said, it is technically C++, but this would compile as C pretty easily with very few changes. To get an idea of the amount of code that's generated here, let's go to this project directory. So about 7 kilobytes of code was created. I think there's some resources created as well. That's this RC file, so that's probably that icon. You'd also have an ICO icon file. The output files go in that debug directory you see here. If it were doing a release build, then it would go into a release directory by default. Anyway, like I said, this is not MFC, but it is kind of interesting, so I just wanted to show that to you real quick. Creating a new application, this time using MFC, we're going to choose that MFC category under the new projects, project templates, and this time we're going to choose MFC application. I'm going to put it in a different directory. And we're going to do a little stopwatch application, so I'm just going to call it a stopwatch here. Okay, so this is the first sort of busy wizard page that you have when you're creating a new project. You have a lot of options here. The default is multiple document or MDI application. This is pretty old school. The simplest is a dialogue-based application that has the fewest pre-populated controls, visual components in it. You also have fewer options as far as what you can do. A lot of these options get grayed out or disappear when you choose dialogue-based. So you have a single document, that's the SDI, all the options are available. Multiple document, that's where you kind of have a bunch of documents simultaneously open as child windows of your application. Dialogue-based is where you get a single dialogue. Kind of shows in a little graphical representation up here of what a dialogue would look like. So you usually have an OK and a cancel button, maybe an apply button, but not a whole lot more. You usually don't have menus. You might have sub-dialogues that get created or child dialogues that pop up, but usually you don't have too many sub-menus or sub-forms and dialogues that appear. And then you have another option of this multiple top-level documents which I think just opens what looks like a bunch of sort of main forms. So it gives you a kind of a graphic representation of what the different options are. We're going to go with dialogue based since that is the simplest option. And we have an option here of how to link in the MFC library. We can use that as a DLL, so that's dynamically linked. That means our application code won't actually include the library in the executable. It'll be in a separate DLL file. You will have to have that DLL file at runtime. The other option is to statically link it into your executable, and that means that your exe will be bigger, and you can't change the version of the MFC library underneath or at any time after you build it. It's permanently linked to that version of MFC. So kind of depending on whether your deployment and runtime use cases about memory requirements or disk space or maintainability, extendability, maybe you want to be able to support replacing the version of MFC later without changing the executable or rebuilding the executable, then you want to go with the default of a shared DLL. Here you have another page of options about the style of the frame, what kind of menu items you want available by default. An about box, for example, is kind of gives you the version of the application if you want that. System menu, typically that's kind of like your upper left menu where you have some options like minimize and close, etc. We'll go ahead and go with the defaults here. Now, another page of options, ActiveX controls if you want those. If you don't, you can probably save some code space by turning that off. You have some other options like Restart Manager, which can automatically do things like restore documents and such if you want that functionality. But what I don't know is how you would go back and change these things later if you change your mind. And you go, oh, well, now I do want the Restart Manager. So I'm not really sure how you would go back and re-enable that option later. So you might want to carefully choose your options when you go through this wizard the first time, hopefully get it right. Let me see. So classes that are going to be created automatically, one for the application, one for the dialog. You want to choose your project name carefully. That way your class names are created meaningfully, and if you have to change these later, that can be a kind of a hassle. So it's good to name these things correctly up front. When you click Finish, it's going to create your application. And this is the most basic form of application that I can create in Visual Studio. You do have your sort of basic form with an OK and a cancel button. You also have a palette of controls that you can easily drag into the dialog to add those visual components. There's not a whole lot of categories here. Pretty much that's it. Dialog editor. So these are all pertinent to the dialog. What you won't see here are things like a menu bar, which typically will go across the top. You'd have like file and help, etc. You won't see that as an option here. You also won't see a status bar. Typically on the bottom, you'd have a status bar, which could show multiple panels of text, usually representing the state of the program as it's running. You won't see that as an option. So you're kind of limited in the palette of what you can easily drag and drop here. Let's go ahead and run this application and see what it looks like without changing anything. Actually, let me look at the source code first. Let's go ahead and analyze how big is this thing. Just because we created a minimal application, how much code did Visual Studio, Visual C++ create for us? Okay, so about 10 kilobytes or 1,100 lines of code right off the bat. So it's like boilerplate code. We also have a resource directory. So that's where an icon and another RC file. So we've got two RC files. We've got a solution file. That's that SLN file right here. That's kind of like your workspace file. Your project file is this VCX proj file. So you're not expected to edit those by hand, although they are readable if you want to look at them. XML. Okay. Since we're going to have a stopwatch, we're going to want some kind of representation of the elapsed time. Some options we have are like an edit control, Typically, that would be something where the user could edit it. You'd also probably have a label. You have a search facility here. No label. How about text? Static text. So a static text control is kind of a read-only visual text component, and does not have any kind of frame or background, similar to this to-do comment here that Microsoft put for us, so we can remove that. But let's say we want something that's maybe a little more visually appealing, so we'll go back to an edit control. I think that's a better option here. But there's no code associated with this edit box by default, so to create that, we're going to right-click and say add a variable. And the main thing we're going to do here is set the name. We want to make sure we give it a good name initially, so we'll call it edit box. Now if we want to look at our code that was created, so we have stopwatch, CPP, we have a header file. It's in the dialog header file. So now we have our new edit box, and the type is cedit. So if we want to know what we can do with this edit box, the best thing to do is put your cursor on the class, the cedit, hit F1 for help, and that'll send you to Microsoft's documentation for that class. It doesn't really have much in the way of properties. Everything is kind of a method that you call, so a function call. It has a lot of functions about controlling the limitation of the input and modifying the selection and copying and pasting and stuff like that. But if you want to manipulate the text or get the text, you really want to use these inherited functions from the cwind class. So we got set window text and get window text. So that's how we're going to actually modify the text of that edit box. Since this is a stopwatch application, we're going to want to put the elapsed time in that text. So we'll say do it in seconds, just to be simple. So we'll need to create a timer. And the way you create a timer is you go to the class view, find your dialog. Down here in the properties window, so that's this box here, you have a messages button. You click the messages, you go down to WM timer. And then if you double click, or you do a drop on, or whatever, or drop down, you'll have a option to add an on timer function that gets called every time the timer ticks. And it resets the timer each time. That's what this does. So we can remove the to-do comment. Now what we're going to want to do is keep track of the amount of elapsed time. We'll do this with a static variable. We could also do it with a class variable or a global, but just to keep things simple, we'll create an unsigned long here. That way when it rolls over, it just goes to 0. It doesn't go negative when the number gets too big. We don't want a signed integer here. To assign this to the edit box, I remember I mentioned that inherited set window method, set window text, excuse me. And then you're going to pass it a C string. That's the Microsoft MFC string class. So we need to construct a C string first, but we'll go ahead and call that stir. So that's the name of our string, our C string instance. And when you instantiate them, you just create an instance. You don't have to call new and use a pointer. You just instantiate it directly. And then to assign the current count value, there's a printf style format method. And then you have to pass it a format string. We're going to say it's unsigned long. Now, this is multi-byte, wide byte, so we have to do that to get our multi-byte string constant. And then we're going to pass the count value. And then after we set the text, we can go ahead and increment the count. Now by default, this timer is actually not going to be enabled. So when we run this program, it's not actually going to set any text in here. We could do this, say, on one of these event startups, like on init dialog. The function that we want to call, let's say, is called setTimer. This is a standard MFC application method. And it has a few parameters. Let me see here. I think the first one is the ID of the timer. Next one is the amount of milliseconds till the timer fires. And then you can pass it a function to execute, a pointer to a function to execute. We're just going to use null because we're doing it based on this, this timer handler that's built into the MFC handling. So we don't need to actually pass a function parameter here. We're going to build and run. Oh, look. Okay, so our counter started at 0. It's incrementing and setting the value. And that would go all the way to the limits of an unsigned long, which is 4 billion something, and then it would roll over to 0. So you could use a bigger integer if you wanted, or do something else if you really cared about that issue. Now, OK and cancel don't really matter what we click there. So maybe we want to go back to our resource view. We want to look at our dialog again, so we find it here. Double click. And delete this button. We want to just change, well, cancel's fine, but maybe we just want to change that to close, or maybe we don't even want that button because there's no effect. Yeah, we didn't need those buttons. But let's say we do want a button. Just go ahead and demonstrate how that works. So let's say we want to start with the timer not running. So we will need a button to start the timer and maybe another one to stop it. Or maybe just a checkbox. You could have a checkbox. Let's do that. Let's use a checkbox. Oh, I want to associate a variable with it so I can check it. So just dropping that control into your dialog does not create a variable that you can programmatically access this checkbox. So we'll call it timer enabled checkbox. So the timer's always running, but we don't want this code in the onTimer handler to do anything if that checkbox is disabled. So the way you check it, so we had that, let's go ahead and look again at our header file so we can see what the type is. It's a C button, again, so if you want to look at C button, see what you have available, F1. Again, it's a bunch of methods that you can call. The one we're interested in is called getState. Here it is. And it returns a bitmap. So we have different bits set, and we have these constants we can use to check them. So it doesn't just return one state parameter. It kind of returns like an array of booleans in the form of bits. Kind of very low-level method of checking multiple state values. We want to call that method timer enabled checkbox.getState, and we're going to compare the return value and see if it has that checked flag. And really we want to see if it's not set, then we just want to do an early return here. Or another way to do it would be see if it is set, then do all this code here. You always want to reset the timer though. So let's try that. So it's not putting any text into this edit box because our checkbox is not checked. Now we're going to check it. The counter starts running. And when we uncheck it, the counter stops incrementing. So that the timer is still running. It's just not executing this little block of code here that we have with this if statement. So again, we now know how to start the timer. We could also just start the timer and then kill the timer. There's a function equivalent to this called kill timer. So here's see when set timer. The counterpart is kill timer. Let's go back to our dialog. Let's go ahead and add a button to kill the timer. So I don't like these names, so I want to change this over here. The caption, we'll call it stop. And then check caption enabled. These are a little bit better names. And then, so when you double click, it creates an event we want to call kill timer. I think you have to pass the ID. Yeah. So it's enabled, it's counting, but we also have another way to stop it, and that just calls that kill timer. So now the timer's not firing, it doesn't matter the status of this checkbox. So this maybe not be a good maybe this isn't a good application design, having two different ways to stop the timer, but I'm just kind of demonstrating the different ways to control that timer. And so you probably want a counterpart, which would be like a start stopwatch. So drag another button over here. Start. And we'll move this set timer. So this is where this timer started. We're going to move that to the on click for the start button. And it's not just the text. I don't like the names of these buttons. So we get these macros that get created for the button name. So this is the start button. And this is the stop button. Okay, so because I didn't name it nicely to begin with, we've got some kind of cryptic names here that don't automatically get updated. So we really want this to be this is the start button and the stop button. So you can see it's pretty important to name your components meaningfully the first time before you start creating events. So on button clicked start button. Object is the end of the name. And then we have these two events that are not going to be automatically updated in our header file, so we have kind of manually rename all these things. And our checkbox isn't like a kind of an event there for a checkbox. We don't really need that. I think that was accidentally added when I double click something. So luckily these are the same signature. Whew. So that's kind of a pain. So the functions are actually named right. Well, you can look at it either way. The content was wrong, was backwards. So enabled, and we're started. You click stop, it stops. Start again, it restarts. Very simple stopwatch. We have an edit box, a check box, and two buttons. There's your very simple MFC application created with Visual C++. Now that we have our application complete to this point, let's double check how much code we have generated. We're going to use the word count program. That's this WC utility, common Unix utility, all the source code CPP into H files. So we know we started with about 1,100 lines. I think it was 1,150. And now we're at about 1245, so about 100 lines were added to the code. I didn't type 100 lines, I maybe typed 2 or 3 lines, so that's how much code was auto-generated by the IDE, and then like I said, maybe a couple lines that I typed. So it gives you an idea how much total code and how much is that is boilerplate, which is 90+% of it.